Yes, ma'am.
Yes, yes. Okay. Um, okay. So I've told you the three types of test bench. One is linear test bench, and the next one is a randomization test bench, and the third one is task-based test bench. Okay, task means the task and functions. What I'm telling is task. Okay, task method. All right. So we'll see. We'll look into it like three types of test bench with a code only. Okay, I'll explain that. Okay. And all these things you don't want, I'll just explain in my own way, okay, so that it'll be easy. What all the things you will be doing inside your test bench is, after writing your design, okay, what you will be doing is, keep in mind, or if you want a note of it, make a note. Okay, first thing is, you need to instantiate your DUT inside your test bench. Okay, because when till this much time you will be running or simulating or compiling your DUT only in your tool. I don't know what you're using, like model sim you're using, I guess. Okay, so you will be compiling and simulating your design until now. Okay, but when you are going to deal with the test bench, okay, you need to simulate or compile your test bench because it is the part of verification. So you will be simulating your test bench. Okay, so that you need to instantiate your DUT inside your test bench. Okay, one thing is, this is the main thing you need to follow inside your test bench. You need to instantiate your design. Okay, and the second main thing is, okay, so inside your module the inputs will be given as a wire, whereas your output will be given as a reg. It is quite common, right? Input will be mentioned as wire and output will be reg. But in the test bench, it is like vice versa. Why it is like vice versa? My inputs will be declared as a reg and my outputs will be declared as a wire, because I am giving some values or stimuli or possibilities of inputs to my A and B. Okay, so my A and B needs to hold some value. Okay, my A and B need to hold some value and then it need to drive to my DUT. Okay, so that holding takes care of your reg only, right? Your reg is a process of holding the data or storing the data, but wire is like just a connection. It cannot store or any hold the value, right? So in case of test bench, I will be passing or I'll be randomizing values to my inputs only. Consider if it is AND gate, I'll be passing something to my A and B. So they need to hold some value. So I'm making them as reg here. Okay, and my Y will be a wire here. Okay, so when compared with your design and test bench, this will be the difference. Okay, so the first thing is you need to instantiate your DUT, and the second thing is you need to be sure with the data types. And why we use a reg and wire, I've told you, right? And the third is inside your initial begin, because since it is a module, you need to write everything inside an initial begin if it is a procedure. Right, so inside an initial begin, what else you can do is you can pass all your possibilities. Okay, I'll just give an example. Okay, so now keep in mind that the third thing is you need to pass your possibilities, or you'll be passing some stimulus. Means nothing but you are just giving some inputs to your A and B. That's it. Assigning A equals 1 and B equals 0, something like that. Okay, this will be your third step. All right. So yeah, this is what I've told you. Your A and B will be as reg here and Y will be wire, and you have to instantiate your DUT here. And the third step is you need to apply inputs to your A, B, and what all the things you have, you need to apply inputs. Okay, this will be your test bench. The three things you need to follow inside your test bench. Okay, this will be a linear test bench. This is also known as a linear test bench or simple test bench. Okay. Then you will be having $display to display the values of A and B. If you want, you can have that also, $display or $stove, $monitor, anything. Okay, and yeah, that's it. So now you got some idea what is test bench and how I can write my test bench. You'll be having a DUT. Okay, so you'll be instantiating your DUT in the test bench, and you need to be very clear with your data types, reg and wire. Okay, because you're going to force the values for A, B, and C, so it is going to hold some value. So I need some reg here. And the third thing is you need to pass a values to your inputs, A, B, or C, any what all the inputs you have, you need to pass the stimuli. Okay, yeah, this is how you need to write your test bench. All right, and okay, I'll give some example for your linear, randomization, and task-based test benches. Okay, so okay, so you can see this GVM editor, right? Hope you can see this. I'll consider one half adder. Okay, your combination circuits. I'll give some example for your combination circuits. Okay. Okay, so first I'll design your half adder. Okay, hope you know how to design your half adder, right? So, okay, what all the inputs will be having in half adder, like A, B, then the outputs are sum and carry. Okay, so my input will be A, B, and my output going to be sum and carry. And I'm going to have some concurrent statement here, like assign. I'm going to directly give assign sum equals A XOR B, and my carry equals A and B. Right? So this is my duty. I need to verify whether this is working properly or not. So I'll be writing a test bench. Okay. So half adder test bench. Here I've told you, you need to make your A and B as a reg. So I'll be explicitly giving I'll tell why I'm giving like hyphen T and all those things. Okay, this is going to be, and the same signals. This A belongs to this A only, and this B also belongs to this B only. But I need some differentiation, so I'm giving some different name. Okay. Okay. So again, I need to declare my outputs. So wire sum T and okay, and I've told you you need to instantiate your half adder here. So half adder DUT means half adder. This HA is the module name. DUT module name HA, and then give some name. It is up to you. You can give any name here. Okay, but this should be same as this module name, and yeah, you can give any name here like DUT, or it is up to you. You can give any name here. Okay, and this is how you need to instantiate. Dot A means this is like connecting these both the signals, this A and this A, or it is telling that these both the signals are same. Okay, and connect for 5 signals also, I mean 4 signals also, you need to do the same. Okay, so our 3 steps are over, like instantiation and then you have to be clear with your data types. Then inside initial begin, what you need to do, you need to pass the possibilities or stimuli. This is also known as stimuli. Okay, so what all the things I can pass for my A and B? What are the possibilities I have? Since it is like 2-bit, I can have like 4 possibilities, like 0 0 0 1 1 0 and 1 1, right? So I'll be passing like a 0, then my B 0 0 1, then 1 0 1 1. Okay, and give some delays between them, like give some delay like #5, some 5 nanosecond delay. Okay, and then you need to know the values of A and B and the value for your sum and carry also, right? So have some dollar display or dollar stop, it is up to you. Okay, I can have dollar display also here, no problem. Okay, I'm going to display the values. And my B value, okay. So this is known as your linear test bench, only this much. Okay, the three things: the instantiation, be clear with your data types, and then pass the possibility values, and then have some display statements. Okay, yeah. So any doubt in this, or any doubts in your test bench, how to write your test bench? I'll give one example for your sequential also. Okay.
No, ma'am.
Okay, good. Yeah, so I'll give an example for your sequential. I'll take some, what is that? D flip flop. Okay. Okay. So your D flip flop module, here you will be using your clock. Okay. So only thing in difference between your combinational and sequential, you need to generate your clock inside your test bench. Only that will be the difference. We'll see what all the things we have. Reset, then your D in, then your output will be your Q. Okay. Okay. So if my reset is 1, then my Q will be 0, else my Q should be 0. Okay, so this is your design for your D flip flop. Okay, so I need to now verify this. So I'll be having a test bench. Declare all these signals. Okay, so here reg clock, then reset, then delete. Then instantiate it. Okay, so after you're doing your instantiation, what you need to do inside initial begin, you need to pass your values. Okay, before that, you need to generate a clock here, right? Because you have a clock, you need to generate a clock. Okay, so initially I'm going to make my clock to be 1. Okay, and after that, this is how you need to generate your clock. Hope you know this. Right, and then one more initial begin, I need to pass my stimuli, right? What are the possibilities you have for your reset and dein? Everything is going to hold like 1 bit, so I'll be passing like zeros and ones. Okay, so for my reset, I'll be passing initially okay, and then 0. Since I'm giving a non-blocking here, it is not going to block if my reset and dein is not going to take consider ones and zeros. Okay, otherwise it will get blocked and your system will get hanged. Okay. Okay, and in between you need to give some delay because all at once it cannot check. Okay, so give some 5 nanosecond delays. Okay, and then since you have generated your clock forever, I'm given like forever clock here, I need to stop it at some time, otherwise your simulation is going to happen and it is not going to stop, right? So I'll be using a stop a task here, dollar stop or dollar finish, anything you can give. So after some 20 or 25 is enough, right? 5 yeah, 25, I'm going to use my dollar stop. Okay, and then have some display statement if you want. Dollar display, you can display the values of reset and dein as well as your queue. Okay, so this is the example for your sequential circuit. You'll be having a module. Okay, you'll be writing some test bench. What is the difference is like you will need to generate a clock here inside your test bench. Okay, that only will be the difference when you are comparing with your combinational and sequential. Okay, and when you are going to generate your clock, you need something or some time to stop it, otherwise it is going to keep on assimilating. Okay, so generate the clock and then you need to stop it. That's it. Okay, so this is known as your linear test bench. Okay, and the second one I have told you, you are going to have some randomization, right? Randomized test bench. The second thing is it is a randomized test bench. Instead of forcing values directly like 1 and 0, either in both sequential and combination, I'm telling 1 and 0, I'll be using $u random here. Okay, so I'll just give an example for that also, but I need to repeat it for some time, right? Because my randomization should not fix, or it should not be randomized only once. If it is going to randomize only once, then there is no use, because I'm going to randomize this reset t. Consider I'm going to give like $u random, $u random or $random. Okay, anything I'm going to give this, but it is going to take either 0 or 1. Okay, so if I'm giving like some repeat or some loop or like for loop, okay, so it is going to randomize like 0 1 0 1. It is going to randomize till the limit. What is the limit I'm going to give? It is going to randomize till that much time. right? So I'll be giving like for int I equals 0. I need to randomize for like 5 times is enough. I plus plus. Okay, and then for reset I'm going to randomize, and then I'm going to randomize my DN. Okay. Yeah, any doubt you can stop me in between and you can ask. Okay. Yeah, this is what your randomization. Okay, I think I'll mute you. Okay, so this is your randomization test bench. Okay, instead of giving the value explicitly like zeros and ones, you are going to give like $random. Okay, but you need to have some time period, then only it can hold like, or it can generate like zeros and ones throughout the simulation, right? And then give stop since you have generated a clock. Okay, this is the second type of test bench, randomization test bench. Got it?
Yes, ma'am.
Yes.
Yeah, ma'am.
Okay. So the next is like your task-based test bench. I'll show example in this, maybe a D flip-flop or half adder you want. Okay, I'll just explain with the sequential because you're going to work on clock only every time, right? So the task-based test bench is like, yes, what value it will take if you use $random? It will take like zeros and ones because your reset is 1 bit. Okay, it is going to hold like 1 bit. 1 bit means the possibilities are 2, so like zeros and ones it is going to hold, or it is going to take like zeros and ones. Okay, yes, yeah. And now we'll see the task based. Okay, so here inside initial begin, this will be a different case. I think I'll have one more because if possible I'll share this, so I'm not going to delete anything here. Okay, consider this D flip-flop. Okay, so instead of that passing values explicitly or randomizing, I'll be going to have a task-based test benches here. Okay, so the task-based is like what you will be doing is at the end you are going to write a task. Okay, you can give like this only, any name you can give, task name. Okay, okay, this is your task. All right, and then here you need to write input reset. Okay, I'll tell why you are going to write this. And what you're going to do is you're going to now match, or you are going to connect this reset I with this reset T, because through this task I'm going to pass the values for this T, and this is going to give values for this reset. Okay, so we'll see, this will be like 3-layer hierarchy. Keep in mind your task based will be 3-layer hierarchy. So here I'm going to connect all these things. So my reset T will be given like this. Okay, means I'll be forcing values for my reset I, D in I and Q, and for these two, and I will be connecting this with this reset T. So which means if I'm having a value 1 here, then I'll be giving the value 1 to my this signal reset T. Okay, and this will be passed to this reset. Okay, so this will be like 3-layer hierarchy. Okay, and similarly for my dt also I'll be giving the values which I'm going to generate in my d in I. Okay, and what I need to do is, you can give some delay or you can have some setup, hold time and all those things here. Okay, have some delay like a 6 because it is like setup and hold time and I don't want it in exact passage of clock. Okay, have some delay here, and what I'm going to do is, again you can for some values. Again you can for some values. Okay, and after some period of time, give 11, you need to do one thing. You need to compare the result. Okay, in task based, the main thing is you need to compare the result. The task based, you need to keep in mind it is a 3-layer conversation and it is like a comparison process. You need to have some comparison process here. These two things are main inside your task. Okay, so comparison process is like, if my q p equals qi, then have a display statement that it is verified, else okay. So what I'm going to do is, either you will be passing, I told you will be passing some values to your reset I, and this will be given to your reset t. This is your second layer, and finally the third layer. Okay, either you can give like this, or you can directly pass 0 and 1 or any values, like any values, it is up to you. You can give like 0, or you can give like x values, or you can give like z values. Consider I'm going to give like one tick bx only here. Okay, so when I'm giving x, then obviously my output will be x, right? So if I'm giving x here, then my d in I also is going to get x, so that my, what is my module? My q will be equals d, that is my d flip flop, q equals d. So my qt should be x and my qi also should be x. If these both are correct or these both are compared, then I need to get a display statement as verified, else not verified.
Ma'am,
Yes, yes.
if why we need task? If the program can be done easily, then why we go for task?
Okay, so task based, yeah, you can have like, you can explicitly, you can give values or you can give randomizations here, but if you cannot do any comparison process there, you are going to give explicitly the values and you are going to check with the display statement or store, as well as for your randomization also, right? Like here you can have a display, right? You don't have anything to compare here. You cannot compare here, right? So I'm going for my task based system, so that if I can pass values for my reset I, d in, and yeah, reset I and d in, then obviously my queue will be producing some values, then I'll be checking the, or I'll be comparing this qo, okay, qo with this qt, okay, this qt. Okay, you will be having some comparison process when you're moving with your task based randomization or test bench, I mean sorry, task based test bench. Okay, so this is the process, main process. You need to go with the task based. Yes,
And
any.
then which stimuli? Yes, ma'am. Then which stimuli derive q underscore I or q underscore t?
Which is going to derive, you're asking? I'll be passing, I'll be calling this task here. I'll tell the next, I'll be calling this task and I'll be passing the values 1 0 or 1, any values I'll be passing here. Okay, so 101 is like I'm going to give values for my reset D in and Q naught. And I can give any number of possibilities by calling. I can pass any values here, like 0, 0, 0, 1, all these things. Or 1, 0, any values you can give, or you can give like 1, 1, 1 only. I'll be calling this task and I'll be passing the values. Okay, these values now we should go and sit inside this reset T. Okay, and this should be passing to this reset also. Okay, then only it is going to check the DUT, right? So once it is going to get passed, okay, it is going to check with the QT. Okay, Q output of this. If I'm giving like say D in I have passed. In first case I have passed like 0. Okay, so now my D in holds 0. So my Q should be 0. Okay, so this is going to be verified, or this is going to get compared. So I can do this process only in this time.